Neural networks are a powerful type of artificial intelligence that are transforming many industries. They are inspired by the structure and function of the human brain. Just like our brains, neural networks are composed of interconnected nodes or neurons that process information. These networks excel at recognizing patterns and making predictions based on large data sets. This ability makes them suitable for a wide range of applications, from image recognition to natural language processing. The impact of neural networks on our daily lives is growing rapidly. From personalized recommendations on streaming platforms to self-driving cars, neural networks are shaping the future. In this essay, we will explore the fundamental concepts of neural networks, their real-world applications, and their potential to solve complex problems. Imagine a network of interconnected neurons, each responsible for processing a small piece of information. This interconnected structure is the essence of a neural network. Just as our brain learns from experience, neural networks learn from data. Each connection between neurons has a weight associated with it. This weight determines the strength of the connection and influences how information flows through the network. During the learning process, these weights are adjusted to improve the network's accuracy in making predictions. Think of it like training a dog. You reward good behavior, strengthening the desired actions. Similarly, in a neural network, correct predictions reinforce the connections that led to them. The power of neural networks lies in their ability to learn complex patterns from vast amounts of data, often beyond human comprehension. Neural networks are already being used in a wide range of applications, and their potential seems limitless. One prominent example is image recognition. Neural networks can be trained on millions of images, learning to identify objects, faces, and even emotions. This technology is used in self-driving cars to recognize traffic signs and pedestrians. It also powers facial recognition systems used for security and authentication. Another transformative application is language translation. Neural networks can learn the intricacies of different languages, enabling real-time translation of text and speech. This has broken down barriers in communication and facilitated global collaboration. From healthcare to finance, neural networks are being deployed to improve diagnostics, detect fraud, and personalize customer experiences. A typical neural network consists of layers of interconnected nodes. The first layer is the input layer, which receives the data. The last layer is the output layer, which provides the prediction or classification. In between the input and output layers are hidden layers. These hidden layers are where the magic of neural networks happens. Each hidden layer processes the information from the previous layer, extracting features and patterns. The more hidden layers a network has, the more complex patterns it can learn. This depth allows neural networks to excel in tasks that involve intricate relationships within data. The connections between nodes, weighted and adjusted during training, determine the flow of information and the network's ultimate output. Section 5. The learning process. Training neural networks with data. Training a neural network is like teaching it to perform a task. We provide the network with a massive data set, along with the desired outputs for each input. The network then adjusts its internal weights to minimize errors in its predictions. This process, called backpropagation, involves comparing the network's output to the correct answer and adjusting the weights accordingly. Through repeated iterations of training, the network refines its connections, gradually improving its accuracy. The quality and quantity of training data are crucial for the performance of a neural network. A well-trained network can generalize its knowledge to make accurate predictions on new, unseen data. Section 6. Step-by-step guide. Building your first neural network. Building a basic neural network is more accessible than you might think. Here's a simplified step-by-step guide. First, define the problem. Clearly define the problem you want to solve. For example, you could build a network to classify images of cats and dogs. Next, gather and prepare data. Collect a dataset of labeled images of cats and dogs. Pre-process the data, resizing images and converting them into a numerical format. Then choose a framework. Select a deep learning framework like TensorFlow or PyTorch. These frameworks provide tools and libraries for building and training neural networks. After that, design the network architecture. Define the number of layers, the number of neurons in each layer, and the activation functions. Once that's done, train the network. Feed the training data into the network, and adjust the weights using backpropagation. Next, evaluate performance. Test the trained network on a separate data set to assess its accuracy and generalization ability. Finally, deploy and iterate. Once satisfied with the network's performance, deploy it to make predictions on new data. Continuously monitor and refine the model for optimal results. Section 7. The future of neural networks, advancements, and possibilities. The field of neural networks is rapidly evolving, with new architectures and algorithms emerging constantly. Researchers are exploring techniques like deep reinforcement learning, where networks learn through trial and error, much like humans do. Another exciting area of research is generative adversarial networks, or GANs. GANs consist of two networks that compete against each other, leading to the generation of incredibly realistic images, videos, and even music. As computing power continues to increase and datasets grow larger, the capabilities of neural networks will expand exponentially, unlocking solutions to some of humanity's most pressing challenges. Section 8. Societal impact transforming industries and our lives. The widespread adoption of neural networks is already transforming industries and our daily lives. In healthcare, neural networks are assisting doctors in diagnosing diseases earlier and developing personalized treatment plans. In finance, they are used to detect fraudulent transactions, assess credit risk, and automate trading strategies. The transportation industry is being revolutionized by self-driving cars, made possible by advances in neural networks. However, the rise of AI also raises ethical considerations. It's crucial to ensure that these technologies are developed and used responsibly, addressing concerns about bias, privacy, and job displacement. Section 9. Conclusion. Embracing the neural network revolution. Neural networks are a powerful tool with the potential to revolutionize countless industries and solve some of the world's most challenging problems. By understanding the fundamental concepts and embracing the possibilities, we can harness the power of neural networks for the betterment of humanity. As we continue to unlock the secrets of the human brain, the future of neural networks promises to be even more transformative, shaping a world where intelligent systems augment our capabilities and drive progress in unimaginable ways.